So sorry, I think I clicked my mic twice. So instead of unmuting, it was muted. Can we hear me now? Good evening, everyone. Is the audio fine now? Can we hear me? Okay. All right. Thank you very much for that. Thank you, Grace. All right. So good evening, everybody. Trust our day went well, and some of us enjoyed the public holiday. And many of us observed the public holiday on our end. You didn't go to the office today. Some of Grace, sorry about that. Sorry about that. Some of us did not go to the office, but we're working. We're working and working, basically. Oh, that's nice. That's good to hear. Happy that the rain cooled the environment. That's very good. All right. So, welcome to another week. This is week 5 of uh, of this training. If you have made it thus far, you've done very very well. I'm proud of you, and I believe you will see it through to the end. Okay, so this week we're going to be looking into networking. I remember last week we talked about storage, and we talked about different storage types, right? Can anyone remind me of some of the storage services that we talked about? EBS, S3, good. EFS, nice. Yeah, thank you. So S3, EBS, and EFS were majorly the storage services. And I know Mr. Moses also talked to us about disaster recovery and backups as well on Thursday. So hope all of those things were well understood, and we can move on to the net. I'm saying EPS. It's EFS, so not EPS. So it's EFS. All right. So today or this week we're going into networking. A disclaimer, right? Networking is an aspect that if you're not careful, you get easily confused, right? So we're going to be sticking to what you need to know for your level, right? I've also added additional resources that you can go and read up on. But networking, I think talking about some specializations in AWS, there's specialization in networking. So that's to tell you how deep and how broad it can be, right? And networking is not just applicable to AWS, it's applicable to every aspect of computing, right? So it's a very broad topic. So we're going to be restricting this to what you need to know at your level. For those that maybe going on, you want to specialize in networking, hey, you can go deeper. Maybe when we do an advanced class, we can now start digging deep. So please, today we're going to take it as slow as possible. Um, Wherever it is you don't get anything, just feel free to call my attention back to it. Okay, so let's get started. So today, like I said, this we are looking at networking in general, but today we're going to be focusing on the virtual private cloud. So before we go into what the virtual private cloud is, let's look at what networking is, right? Generally, since that's what we're talking about throughout this week. So what is networking in AWS? So networking is basically the connection and the communication between your resources. Whatever it is you have in the AWS is your resources, be it a database, be it your server, which is your EC2 instances, right? Or the application you are hosting on the server, or your S3 buckets, or your EFS or your EPS. All of those things are what are resources. Now, how they all communicate with each other, how it is that, oh, you're saying, oh, this database here should be talking to this EC2 instance there. How that communication happens without there being a miscommunication, so to say, is basically what networking is. So networking is what manages communication and connection of your resources in AWS, right? So basically AWS provides you with the tools that you can use to manage these connections. So why is it important that we talk about networking, right? Just like um different roads, right, connect different places in a city is important, because so that you don't, if you are going to Ibadan, for example, right, and you are at Bega, and you're going to Ibadan, it is networking that helps you to know that, oh, there's this road is one that leads to Ibadan. If you decide to go and pass maybe north, you'll probably be heading towards Yanowo, right? Which is the wrong route to be taken. So networking is what helps to help us understand where we're supposed to be going, what road leads to that place, right? And it also allows for exchange of data and different other things. So how does AWS help? Again, like I said earlier, it provides you with the tools that you need to create. So there are different tools like your VPC, Route 53, Direct Connect. So I'm not looking at Route 53 today, right? So um, I'm going to check if it's still further in our curriculum. If it's not, we'll probably just add it in basically, right? So we'll just make a mention of it, not something very that we're going to be going very deep into. So, what is the key concepts in AWS networking? What are the concepts of the other concept that we have in AWS networking, right? We have VPC, which is your virtual private cloud, and that is, you can think of it as your own private. This is what we're going to be focusing on today. So don't worry if the definitions you are seeing here does not cover it for you. We are going to go and dive into it properly. So you have VPC, you have subnets, you have your CIDR blocks, right? CIDR is actually an acronym. We're also going to look at it in the slides today, but it's pronounced CIDR. So you have your CIDR blocks, you have IP addresses, you have your elastic IP address, you have route tables, you have gateways, VPC peering, network access controllers, that's your NACLs, and security groups. So these are the basic concepts in AWS networking, and these are what we are going to be covering throughout this week. All right, so let's get into um today's one basically. Hope you can all still hear me. Can we all still hear me? Okay, all right, thank you very much. And apologies in case you hear me sniffing. I have cold and catarrh, so I might be sniffing um maybe often than usual. All right, so let's get into today's one. So VPC, what is VPC? VPC is an acronym for virtual private cloud. Virtual private cloud, that's what VPC is. So whenever you hear us say VPC, or wherever you come across VPC, just know it is, at least when it's relating to computing, it is virtual private cloud, right? And it's like your own private section of the internet within the AWS cloud, right? So it's like your own private section, is like your own personal space within the AWS cloud, right? And it also securely isolates all your resources. So for every resource you are going to be having that you want to put in the cloud, in the AWS cloud, they are expected to be sitting within a VPC, because the VPC is what is basically saying, okay, this is my own space, right? And I said an analogy of it is a VPC is like your school campus, right? You purchase a land, maybe you want to build a school campus, and you understand why I use a school campus later on as we go on, right? So it's like you purchase your own land in Lagos State, for example. You purchase a land that you want to build uh, an higher institution in, right? So the VPC is like that's land that you bought, right? It is your own personal space. you have the rights to it. You have the documents to it. It belongs to you. So nobody can, anybody that just comes there, right, is trespassing basically. So it is a private and a secure area within the larger city, which in this case is the AWS cloud. And it contains multiple buildings. These buildings are your subnets and different gates. So these gates are the one that control access basically. So what are the components of a VPC? You have the subnets, right? And subnets are like your buildings inside that land that you bought, right? Remember, we're building a school campus, right? So the school campus is the entirety of the land that you have, right? So subnets are buildings inside that campus. Like you have your hostel buildings, you have your Senate building, you have different faculty building, right? You have what other kind of buildings do you find in school campuses? You should understand what I'm saying, right? So subnets are like those buildings. And what the subnet does is that it helps you to have an organized space for your resources. So it helps you to have organized space for your resources. So you are not putting bed in a, let's say for example, right? Hostel is supposed to have, beds, bunks, and all of those things, bedrooms. You are not putting those things just anywhere in the VPC or in your campus. They are going to be within a building. So the hostel building is what is going to be housing things like your bed. So your resources are not just scattered everywhere, right? It is within a confined space. So your subnet is like those buildings. Then CIDR is basically what determines the number of right? Rooms in this case is your IP addresses, right? Within the building. Rooms are your IP. So basically you're building an hostel, for example. So CIDR is what determines the number of rooms you will have in that building. Say the number of rooms you probably have in an office building, right, might not be as much as the number of room you have in an hostel building, right? Because it's expected that the hostel building is going to house more resources, right? So that's what the CIDR is for. We're going to still expatiate on all of this for. Then your route table is like your map, is what shows you the paths. Where are you if you are going to Faculty of Science building? How do you get from Faculty of Engineering building to Faculty of Science building? Or how do you get from I went to Unilag, I'm trying to remember the name of an hostel. Okay, so let's say from Jaja Hostel, right, to Faculty of Science building. It is your route table that shows the pathway, the things, how the routes are configured. This is where you will pass to get to this place, basically, right? Then gateways are like your, of course, just like the name sound, they are your gates, right, or your doors. They're the one that control access in and out of the campus and also in and out of your buildings, right? So we have a main gate. We're going to talk about that later on, right? You have a main gate that controls access into the campus, but every building also have their own different access control. It could be a door, it could be gates. Some faculty will have gates, some faculty will have doors that you have to enter into to get to the things that are inside that building, basically. All right, so let's now go deeper. Please, I'm going to be checking the charts frequently because I want us to be dealing with any issue you have as we go on. So CIDR, what is CIDR? Like I said, is an acronym, and what it stands for is classless interdomain routing. Classless interdomain routing. Now, for those that will probably specialize in networking before now, you know that these are there are different things that has been used in the past, right, for routing of IP addresses or for naming conventions of IP addresses. There used to be the stateful one, but CIDR is the one we're using now, is the current one that we use. So it is what determines, like I said earlier on, is what determines the number of IP address in each subnet and even in the VPC as a whole. So what that means is, for example, you've bought a land, right? We said the entire campus is your VPC. So the amount of land, right, that you have is what is going to determine the amount of building that you can put into it. Let's say, for example, if you buy only 4 plot of land, you cannot build buildings that are going to be more than 4 plot of land inside that VPC. So your CIDR is what determines the size of your VPC and also determines the number of rooms in each building that will be in that VPC, right? So what are the components of CIDR? You have the CIDR block. Now, the CIDR block is the one that determines the amount of IP address that you have, right? It determines the size of your subnet. Remember, we say subnet is like your building. So it's what determines the size of your building. And it uses specific notations. Now, we're not going to dive deep into breaking down what this notation means, but I'm going to tell you the one that is important for you to know and understand in that notation, right? So it has a prefix and a suffix, right? That's a prefix and a suffix. So the prefix is basically your network address, and the suffix is your network mask. So this is the notation is usually written in a x.x.x.x/y. So usually 4, right? So those x are your prefix. Anything after the slash is your suffix, right? So that's why you have x.x.x.x/y. Now, the x.x.x.x is the network address, while the y is when you have to pay attention to a lot, right? Because that is what will determine the size of your network, is what will determine the size of your subnet, is what will determine the size of your VPC, basically. So the Y part, again, like I said, the slash Y part is what determines how many IP address that um your CIDR block would contain. And please note that the smaller the number, the larger the block of IP address. So basically, the smaller the number at the back of the slash, the more rooms, the more IP address you are going to have. And these are some of the common CIDR block address that we have, right? So you can have a /16 /24 /28 /16 is actually the largest, right, I'm aware of. And if you have a /16, right, let's say you've gone to go and buy a land, and in that land, when you went to the person that is selling, you say, oh, I want a /16 land, right? What it means is that in that, let's say our IP address, each IP address is a plot. Let's assume, right, that each IP address is a plot. So you can say that in that /16 land, um, land that you're buying, you can have 65,536 plots there, right? So that's what a /16 does. /16 will give you 65,536 IP address. Now, if you have a /24, a /24 will only give you 256 IP address. So you see that even though the /24 is supposed to be bigger than the /16, remember what I had said here, that smaller numbers mean more IP addresses. So that's why you can see /16 will give you 65,000, right? /24 will give you 256 IP, /28 will give you 16 IP, right? So they are much more. There's /20, there's /22, depending on what you want, basically, right? But these are the common ones that are majorly used. Now, what does this basically relate to, right? If, for example, the kind of campus I want to build, right, a school campus that I want to build is just the one that is only maybe only science students that will be there, right? I will not need so much, right? Because all I would need is probably the one faculty that will be there, the building faculty, maybe the admin faculty, a library, and maybe one hostel or two hostel, male and female, right? So I might not need that much space. So I can decide to just buy a /24 land, right? Which will still give me about 256 plots that I can use to do whatever I like. So a /16 IP address, /16 CIDR block rather, is ideal for large networks. Companies that know that, oh, we have a lot of resources, we have a lot of things that we're going to put. And so your IP addresses, right? They're like your room number. Every resource have an IP address. Your laptop has an IP address. They're like your PO box. Basically, it's personalized to every resources. If you create an EC2 instance, it's going to have an IP address. If you create a S3 bucket, it's going to have an IP address. If you create 10 S3 bucket, each of them will have IP addresses, right? If you create 10 instances, each of them will have 10 different IP address. So IP addresses are unique to the resources, right? So if you know that, if it's a company that know that, oh, we're going to have a lot of resources, it is usually ideal to use /16 because it gives you a larger amount of room to play with, right? There will not be case of, oh, we don't have enough room to build again. So /24 are for smaller network, a smaller network to your /26. /28 is smaller than /24 and so on. There's /32 as well. So that is a CIDR block. Now, an IP range. An IP range, in a way, you might feel like, oh, it's similar to a CIDR block, but it's not. So when a CIDR block, or while a CIDR block tells you the size of your subnet, tells you that, oh, a /24 can only give you 256 IP addresses, right? What an IP range would tell you is that it's going to list all the possible IP addresses that are within that CIDR block. Say, for example, now, if you have a CIDR block that I said 10.0.0.0/24, remember I said the first four parts, this first four elements here, which is supposed to be your x.x.x.x, right, is the network address, right? For now, don't bother your head about it. Don't worry. Concern yourself here first. Concern yourself with whatever is after the slash for now. So if you are looking at this CIDR block that we have here now, 10.0.0.0/24, how many IP addresses do you think, or do you know that this CIDR block would give? How many IP address is right there on our screen? How many IP addresses will a 10.0.0.0/24 give you? Thank you very much, Olayinka. So yes, 256. So we are following. So 256. For those that are still saying 24, no, 24 is what will determine. If you look at what the slide, right, it's telling you that anything /24 will only give you 256 IP address. They are already defined. You cannot you cannot change it. It's defined. It's a defined rule. /24 will give you 256 IP address. /16 is going to give you 65,536 IP address. /28 is going to give you just 16 IP addresses, right? So now we have that CIDR block. If I now say that, how many IP are what are the IP range that I'm going to have in that CIDR block, is now going to be that maybe if I create an instance now, that instance can be given an IP of 10.0.0.0 or 10.0.0.1 or 10.0.0.2, 10.0.0.3, up until 10.0.0.255. Why is it stopping at 255? Because you can only get 256 IP address. So if you count between 10.0.0.0 to 10.0.0.255, you have 256 IP address. What does this mean? It means I can only have 256 resources within my VPC that are going to have this I can only this 20/24 means that I can only have 256 IP addresses, right, for my resources. 256 resources that I can have within that VPC or within that subnet, right? While this IP range means that I cannot give an IP address to my resources that will be maybe 10.0.0.257. I can't do that. So IP range is what lists out the possible IP addresses that you can have within that CIDR block, basically. Do we understand that? Yes, happy. Yes. I mentioned earlier that the smaller that number, right? The smaller the number at the back of the slash. Your CIDR block is not just carrying the slash, it's carrying two different parameters. It's carrying the x.x.x.x slash y. Whatever the number that is after that slash is what will determine the size of your subnet. So the bigger the number at the back of that slash, the smaller the number of IP addresses that you can have. That's why you will see that a slash 16, we have 65,000 plus IP address, and a slash 24 is having just 256 IP address. All right, thank you. So we understand this and we can move on now. Okay, so what are the rules that surround CIDR blocks, right? Number one is no overlapping. Now, this is where we're going to dive a little bit into the x.x.x, right? So, no overlapping is allowed in your CIDR block, which means, for example, you have a CIDR block of 10.0.0.0 slash 16. Now, you've created a subnet. For that subnet, you have to also give it a CIDR block. So number one is that your subnet size must be within the VPC size. Your subnet size must be within the VPC size. What do I mean? If I have already said my VPC, which is a plot of land, right? It's just like I was saying earlier that the number of buildings you will have in your plot of land, right, in your land that you bought for the school campus, is dependent on the size of the land that you bought, right? So if, for example, I bought a land, right, that is 10.0.0.0 slash 16, right? This 16 means that I have about 65,536 plot of land, right, on that land, which means that if I decide to build different buildings on one plot, one plot, it means I can have 65,536 different buildings, isn't it? Now, remember that every building will also have rooms, and these IP addresses also is speaking to those rooms as well. So every building you are going to have, you are going to decide, okay, how many rooms do I want this subnet to have? Remember, a building is inside the VPC, right? The rooms are inside the subnet. So your rooms are like the portion that your each of your resources are going to take. So a subnet is the one that will house your resources. So let's say, for example, now I want to build building one. Building one is maybe the hostel, that female hostel that they will stay, right? So I have 10.0.0.6 slash 16. I can now say that, okay, for hostel I only need 10.0. Now it changes here to slash 1. You can also have a slash 0, right? But what happens here is that you cannot have two subnets having the same number here. Say, for example, I cannot say, oh, my first subnet, and that is what overlapping means, right? I can't say, oh, my first subnet will be 10.0.1.0 slash 24, and then the second subnet will now be 10.0 slash dot 1 again. It's going to tell you error, because it means that they are now overlapping. So is what overlapping basically means. For this expert, that is what concerns you there. For now, at this stage, that is the only thing that concerns you. So this third x here, this third zero here, right? If you are going to have different things under it, they cannot be the same. They cannot overlap each other. So, what is the second rule? Is that there's limit. There's a patience. I don't get. You said an existing IPM. I don't get your question. Can you please expatiate more on it? All right. So the second rule is that what a VPC CIDR block ranges from a slash 16 to what a slash 28. Now, it means that basically what you're saying is the government is saying that you cannot purchase a land if you are going to build a school campus, right? You can't purchase a land above slash 16, right? Which is giving you 65,536 plot of land. And you cannot go below slash 28, which is giving you just 16 plot of land or 16 rooms, right? Or 16 buildings, right? So there are limits. For your VPC, you cannot go above a slash 16, and you cannot go below a slash 28. Please let's take note of these things. You can't go above a slash 16 for your VPC. Remember, VPC is your plot of land where your buildings will be sitting. But for your subnet, you can go as low as slash 32. But your subnets cannot go higher than your VPC, which means you cannot have a VPC that is slash 16 and then you now have a subnet that is slash 16. It means that what you are basically saying is that it's only that one building that you want to have there, which is fine. But let's say, for example, I purchased a VPC of slash 28, right? I purchased a VPC. My land, the land I bought is just slash 28, which is giving me just what 16 plots, right? I now said that, oh, the building I want to build inside it, I want to build 3 buildings. Each of those buildings are going to have maybe slash 24, which is 256 room each. It's not possible, right? Why? Because I only have space for 16 rooms. I cannot now say my subnet is going to be 256 rooms. Do we get it? Do we get it thus far? Yes, patience. Yes. So you can't create. Now, this is the thing. The tricky thing is that the VPC is not the one that will create the IP by yourself. You're the one that is going to go and create what you need. It's like you are going to buy land. You're the one that will determine how much land you want. So it's you that will determine whether it's a size slash 16 you want or it's a slash 24. It's you that will also determine whether it is 10.0.1.0 you want to name your subnet or 10.0.2 you want to name your subnet, right? So, yes. So, do we get it thus far to where I've explained that your subnet cannot be bigger than your VPC? Do we get that part? I cannot have a VPC and the VPC is slash 28. And then in my subnet address, I'm now putting slash 24. It means that I'm saying that I want to put a 256 room building inside a 16 room land. It cannot work, right? So we need to take note of those limits. All right. Thank you, everyone. For me, where do you want me to come again? Just type it out. Let me know where you want me to come again. So while Folayami is writing, let's move on to the next rule. The next rule again, like I said, is the subnet CIDR block should be a subset of the VPC. So your subnet CIDR block, right, has to be a subset of the VPC. Say you cannot have a 10.0.0.0 slash 16 for your VPC, and then your subnet is now 11.0. It cannot work. So your VPC, your subnet has to be within this range. That's why your subnet will now be 10.0.1.10.0.2.10.0.3. Continue like that. It has to be within these first two um numbers here. Your subnet will now be following it. It will be following that order. It cannot be 11 dot something. Do we get that part? Then the last rule is that the last rule is that AWS reserves 5 IP address in each subnet for their own internal use. So which means that if you have created a subnet, right, and you have given that subnet a CIDR block of 10.0.1.0/24, we said /24 means that was you have 256 IP addresses, right? Out of that 256 IP addresses, 5 automatically belongs to AWS. I put it in the additional resources we are going to in the slides, right? And you're going to see which of those IP addresses that AWS takes. So which means that if it's just like saying the government is the owner of the land, right? So for every land that you buy, the amount of, if you bought a land that has 256 plots, out of that 256 plots, government is taking 5 plots. And it's not like they're taking 5 consecutive plots. It can be different plots. You can take one plot at the entrance, they can take another plot at the back. So they take that plot to maybe build a building that is maybe for managing or for something. But you have to remember. So which means that if you've created a subnet with /24, which means you're supposed to have 256 IP addresses. You have 256 IP addresses, but know that 5 does not belong to you, which means that you only have 251 IP addresses to play with. You only have 251 IP addresses to play with. Is that understood? Do we get that part? Can I move on? All right. Okay, thank you. Yes, Atinoke, I'm saying that your subnet cannot go higher than VPC. Your subnet is a building inside the VPC, right? Just like your subnet is a building on top of a land. You cannot have a one plot of land and then your building is going to be occupying 3 plots, right? It's not possible. So your subnets are, in quotes, buildings inside your land. So there's no way that your subnets can be higher than the amount of land that you have. Do you get that, Atinuke? Agatha, you're thinking. Please share your thoughts so that I can know if we need to come back. You're welcome, Atinuke. All right. So let's move on now. I'm moving on to subnets. So I think I've already mentioned what subnets are basically, right? Throughout my discussion of CIDR block. So, like again, your subnets are like different buildings within the VPC, or different building within your campus land, right? Now, each building serves a unique purpose. So you can have your classroom, your building of classrooms, you can have your building of libraries, you can have your administration offices, different things. Same thing in computing world. You can have subnets for different things. You can have your application subnet. Sorry, excuse me. You can have different subnets for different things. There's no limit to the number of subnets you can have, as long as it does not go outside of the number of IP address of your VPC, right? Coming back to this example now, I want to use that to explain what I mean by you can have as many subnet as possible, right? Now, this VPC as /16, which means that this VPC, right, asks 65,536. It has the capacity to take 65,536 rooms, right? Now, that is what my land is giving me. Now I'm building the building one, maybe building one for classrooms. For that classrooms, I'm saying that, oh, this classroom is going to have 256 rooms within it. So we're going to have 256 different rooms within this building, or 256 different resources within this subnet, right? So which is why we have what /24. Now I now have another building, maybe building two for maybe administrative office, right? I'm saying that, oh, this building two is going to have 256 rooms. So which means so far now I have how much rooms altogether? How much have I used altogether out of my 65,536 rooms? How much have I used? I've used 512 rooms, right? I've used 512 rooms out of my 65,536, which means that I can still go ahead to create more 256 room, 256 room. I can create about 256 more, right? Or 253 more, right? I can do that. But if I now say, okay, the third building I want to build now is going to be maybe a slash 28. Slash 28 is giving me what? 16 rooms. So I'll just add it and it will keep subtracting it. So the number of subnets you can have is going to be dependent on how much IP addresses you still what you still have available. If, for example, now I have done a slash 16, I decided I wanted to build this building and I want this building to have 65,536 rooms. I've already used up all my space. I cannot go and create another subnet. Do we get that part? Do you understand that? Oh, Agatha, I'm so sorry. Don't worry, I'll try and reconnect everything back, but just follow as much as you can from where we are right now. Right? Okay. So, thank you to everyone that's said they understand and can move on. So, again, your subnet is where your different resources reside, right? So you don't buy chair and just put the chair in the on the land like that. You have a building that is housing it. Let's say, for example, you want to build a laboratory building. All the laboratory equipment, you're not just going to leave them anywhere. They're going to be within the laboratory building, right? Basically. Please give me 1 minute. Please excuse me for just a minute. Thank you very much. So sorry. My apologies. I had to quickly attend to something. All right. So moving on, what are the components of a subnet? Again, component of a subnet is what is also your CIDR block. So you have your CIDR block is going to be associated with your VPC and also your subnet, right? So your CIDR block, you have your route table. We're going to talk about route table. I think that's the next thing. I'm going to be talking about route table. So your route table and your NACL. I'm not going to be talking about NACL at all today, right? It's one of the things that I think we're going to be talking about on Thursday, right? So, but just know that component of your subnets are your CIDR block, your route table, and network access control list, which is your NACL. Okay, so moving on, what are the rules for subnets? Again, unique CIDR. Every subnet has to have a unique CIDR block. They to they must not overlap, right? Also, you have to know that the size of your subnet has to be within the size of the VPC. Like I already said earlier, right? The size of your subnet has to be within the size of your VPC. You cannot have a slash 24 VPC and be having a slash 16 subnet. It does not work. Please also remember that for the sake of those that are just joining, the bigger the number at the back of the slash, the smaller the number of IP addresses you can have. So when you see a slash 16 and a slash 24, and they ask you which one will have more IP address, don't say, oh, because 24 is bigger than 16. It means that 24 will have more IP addresses. It works in opposites. They are inversely proportional, right? So the higher the number at the back of the slash, the smaller the number of IP addresses. The smaller the number at the back of the slash, the higher the number of IP addresses that you have. So another interesting thing to note with subnets is that you can have a public subnet and a private subnet. Now, basically, what's gives the difference between a public subnet and a private subnet? Say, for example, they are both buildings, right? They are both buildings, but a public subnet has access to outsiders, right? Outsiders that are not necessarily staff or student of the campus, right? So a um A public subnet now is like a public building. Everybody can come in. Anybody has as anybody can come into the that building. So a public subnet is connected to an internet gateway. It's like a public subnet is like a building that has connection to the main gate. So anybody coming from the main gate can always enter into that building, right? While your private subnet, they don't have direct access to the main gate. So for anybody to communicate, it's like people that are in prison, for example, right? Like people that are in prison now. Somebody is coming to visit them. They can see the person, right? They can, but the person outside cannot touch them. There's something that is blocking it. Or say, for example, you want to go from this building to you want to buy something at the market, right? But your building does not have access to the market. But your building has access to another building. Let me go back. You have building A, right? Maybe hostel building, right? And then you now have um building for what they call staffs that helps you run errand. You have a building for that, right? So the building for those staffs that run errands is connected to the main gate, which means that things can come in and go out, come in and go out to that staff's building. But for the hostel building for the students, things cannot just come in and go out, come in and go out, which means that if the students need something from outside, they would have to go through another route that is not the main gate, because they don't have access to the main gate, right? It's only the staff's building that have access to the main gate. So it's either they go to the staff building and go and tell them that hey Joe, I want to get so and so from outside though, or my mom is bringing something from outside though. The staff building will help them collect it and then pass it through the hostel building. So that's the difference between a public and a private subnet. Public subnets have access to internet gateway, which means that it can get traffic from the internet, while a private subnet does not have access to the internet. The only way it can have access to the internet is by using another helper thing. We're going to talk about it later when we're talking about gateways. Right. Hope that is clear. Can we move on? Hope subnet is clear. Lydia, I like your question. Nene said American prison is not Nigerian prison. Oh God, yes, like a private lounge, like a VIP section. Can be like that, yeah. Dejere. All right. So, Lydia, you say if you buy a 28/28 VPC at the beginning of your business, and after a while you realize that you need more space for IP, can you scale up? Unfortunately, no. So that's why a lot of people would prefer to provision much more than they think they might have, just in case of future, right? So unfortunately you cannot scale up. It is what you have bought that you have bought. The only other thing is to buy another VPC, to buy another land. So you can buy another VPC. So you it's not just one VPC you can have. You can buy as much VPC as you want in the AWS cloud, right? And I'm saying buy, like, because we're relating to land, right? So if you've bought a /28 piece of land or VPC and you realize that our business has grown, or we'll need more and more IP addresses, right? You cannot scale up. So what you can do is you can now buy or provision another VPC with a bigger space, right? And then you now make there to be a way that maybe there's a resources in the first VPC that you bought, and there's a resources in the second VPC that they need to communicate together. There's something called VPC pairing. I think Mr. Moses will probably talk about that tomorrow, right? That is what will allow them to communicate. So you can always buy as much as you want, basically. Hope that answers your question, Lydia. Okay, so it's almost 8 o'clock. Please, you people should be praying that they will bring light though. My laptop battery is looking at me at the moment. All right, so um Moving on to route tables. So again, right, route tables are like your map. They are the ones that guide data, right, through the campus. So data is like the students or whoever it is that is within the campus, right? They are the ones that contain the direction, right, to different buildings. They contain directions to different buildings. So if you are saying, oh, we're going to Senate building, for example, it is the maybe you are presently at main gate and you're going to Senate building. It is the route table that will say, oh, okay, Senate building, main gate, this is the direction to it. So you're the one that would configure those directions. Now, what are the components of route table? Component of route table is one, your route. The route is the instruction. So if somebody is going from main gate to the uh what do you call it now, Senate building, for example, now, right, the instruction is that that person has to go through Capac B. From Capac B, now enter a bus to Kiniko, right? And it will gives you the route to it. Now, please note that if you do not put a direction for somewhere, let's say for example you have put direction to the main between main gate and the subnet, your Senate building, right? But you did not put a direction for main gate to maybe Faculty of Science building. There's no way anybody can reach there because there's no instruction that guides that movement. There's nothing like, oh, I'm gonna ask somebody. Once there's no route table for it, you cannot go, basically, right? So a route is the instruction that will determine that, okay, this is where this traffic is going, this is where this one is going. Let's say for example, um parents are coming to the hostel, for example, for visiting. Oh, okay, so it will check, is there an instruction as to how parents are supposed to go about it? Oh, okay, there is. All right, so this is how they are going to go. Then another component is the target, is what will determine, okay, there's an instruction for main gate to different places, for example, where is this person going to, where is this one going to? Maybe you say for parents that are coming to visit their children, no, right, the target is what? Maybe the hostel, maybe male hostel or female hostel, depending on who they want to see. Okay, so for male hostel, this is how the person will go. For female hostel, this is how the person will go. So your target is what is determining or specifying where exactly that traffic, that person is going to within your VPC, right? So your targets can be different buildings, your targets can be a particular gate within your land or within your campus, basically. Then associations, right? That's another component of route table. So route tables are associated to subnets. Your route table are associated to subnet. So every building is expected to have a route table. So every building is supposed to have expected to have a map, so to say. So Faculty of Science is expected, that building is supposed to have a map. Maybe the laboratory building is supposed to have a map. The library building is supposed to have its own map. Map from different places, right? So if, for example, I have built the hostel, right? I need to have a route table attached to that hostel building. That route table is strictly what is going to be determining the direction of traffic from the hostel and to the hostel, is specifically for the hostel. So it's going to be carrying instruction of how you can get from main gate to the hostel, from Faculty of Science to the hostel, or from the hostel to the main gate, or from the hostel to the Faculty of Science, or from Senate building to the hostel, or from hostel to the Senate building. It is specific to the building. It's going to carry the instruction, direction of how traffic will be moving to and from that building, right? So route tables are associated to the net, to the subnet, and the subnet uses this route table to guide traffic in and out, basically. So what are the rules for route table? Number one is that every route table or every building can every sorry every subnet rather, each subnet can only have one route table. Each subnet can only have one route table, just like each building can only have one map. So the map is what is going to carry all the direction for that particular building. You cannot have two maps. You have just one map. You can always update the map. You can remove, maybe there used to be a road from main gate to um the hostel, but they have blocked it. You can always remove that road, that direction, that instruction from the map and put the updated one there. Or maybe there used to be that route to the hostel, but you don't want students to pass that route again, right? You can block it and say no more. So somebody that passed there yesterday and said, there's a road from here to the hostel, oh, but because you have blocked it or you have removed that road, if the person comes tomorrow, will not be able to pass that same route. So every subnet, or each subnet, can only have one route table at a time, right? Each subnet can only have one route table. Now, there is a default route table which is called your main route table. Whenever you create a VPC, there's a default route table. It's like whenever you have you buy your land, right? There's a default map. And basically the map is basically telling you that things within the land can communicate to themselves. Movement is allowed within the VPC. So that default route table is basically what is saying there's local communication. Local communication is what is allowed. So which means that if I'm inside that VPC as a staff or as a student, or I'm in the campus as a staff, as a student, registered, I am situated in that campus, I can go to any building within that VPC. I can go into any building within that VPC, right? So that is what the main route table is. Now you cannot delete the main route table. The main route table cannot be deleted, but you can update it. You can add more routes to it, right? Now the main route table is always, like, again, like I said, by default it's created for you once you create a subnet. Once you create a subnet, there's a route table attached to it. If you create a subnet, for example, for um let's say hostel building, right? If you created a subnet for hostel building, so you've created this hostel building, by default there's a route table that gives you the direction from that building to, allows you to communicate with every other building that is inside there. But now you can now add to say, okay, from main gate there's another route I want you to take. You can add it to the route table, right? Then, of course, your route table is what is deciding, is one that makes your routing decisions, right? It's what is deciding whether something can leave the subnet or something can enter the subnet. If there's no route, if there's no route that is dictating that, oh, your parents can enter the hostel, right? If there's no instruction like that in the route table, it will not allow it. Basically, you just be like the road that block. There's no road that leads to it. So there's no road that is linking parents at the main gate to the hostel. So there's no way the parents can get to the students in the hostel, basically. So are we clear on that? Can we Oh, it's past 8 already. Okay, so let's quickly go for can we go for uh our break? Okay, all right. So let's go for our attendance break now. Let's go for our attendance break now. At Ediri, can we drop the attendance link? Oh, Levina, sorry, you came late today. That's true. All right, I'll try and do a recap at the end so that those that didn't join early can still understand. So please find your attendance at the description um on the YouTube page, right? So just go to the description, click on more, and then you find your. For those using a phone, you click on more twice. For those not using phone, just click on more. I'm sure you should be used to doing this thing by now, right? You can private chat me, Levina. You can private chat me or drop your question on the Telegram. I'll try and follow up and answer. But you can please still stay around and listen to the rest of it. You might catch one or two or three things. So please let's quickly fill our attendance so that we can get back to it. Ouch. Grace, sorry. You can always go back to rewatch the video. You can always go back to rewatch the video. Okay. Welcome back, everyone. Hope you stretched your leg a bit. Um, all right. Thank you, everyone. Okay, so we all understood the route table, right? We can move on to gateways. For those that um have missed part of it, just try and follow on from here. And at the end, there's going to be like how everything comes together. So maybe that will help shed more light on some of the things you've missed, basically. So let's move on. Are we all here? Can we hear me? Hope I'm not muted again. Can we hear me, or we're not yet back from break? Okay. Okay. All right, Miriam, you seem to be the only one that is back. Okay, Evelyn, thank you. All right. Nilolawa. I like your name, by the way. All right. Okay, so let's move on now to gateways. So we've said that VPC is like the land you purchase, right, to set up a campus, right? We've said that subnets are like the buildings in the VPC, or the buildings on the land. And we said subnets are the one that houses every of your resources, right? So every resources you're going to start, maybe your EC2 instance, your S3 bucket, your database instance, whatever it is, will be sitting inside a subnet. We've also said that subnets can be for different purposes, right? Just like you have different buildings for different things in a school compound, right? We also talked about CIDR block, and we said your CIDR block is basically what determines the amount of IP addresses that you have. And we said there are two parts of the CIDR block: the network address part, which is your x.x.x.x, right? Then there's the second part, which is after the slash, which is like your y. And we say whatever number is after that slash is what is actually determining the size or the number of IP addresses that you have. And we've also talked about route table. And we say route table are like your maps. They are what carries the instruction out as to how the different buildings or the different resources are communicating. Different buildings are communicating. So you have your route table attached to your subnet. Route tables are attached to your subnet. So every building, every subnet must have a route table. All right. So moving on now to gateways. So what are gateways? Like the name implies, gateways are like your gates or your door, right? They are the one that control the entry and the exit points for your VPC, right? They control entry and exit. Sorry, excuse me. So there are different type of gateways. Three of the ones that we're going to be talking about is the internet gateway, your NAT gateway, and your VPN gateway. So your internet gateway. So internet gateway is like the main gates of the school campus, right? I said it earlier on. It's like the main gate of the school campus. It allows a two-way traffic. Two-way traffic means that the students within the campus can go out, right? The people outside the campus can go in, which means that data from any of the subnets, right, or any of the resources can always go outside of the VPC. They can communicate to the internet basically, and the internet can also communicate to the VPC. So um, like your maybe if you have a web application now, right? If you develop the web application and you put it on AWS, and you want a situation whereby you want people to be able to access that application that you have hosted on AWS, it means that that VPC that you have, or the subnet that you are going to put that particular application, right, has to be connected to the internet gateway. You must have an internet access. Remember I said there's public and private subnet, and I said the difference between a public subnet and a private subnet is that a public subnet has access to internet, while a private subnet does not have a direct access to internet, right? So an internet gateway is basically what allows traffic from the internet to your VPC, or from your VPC to the internet. It is also what enables public IP addresses to be attached to your resources. So there is public private IP address, there's private IP address. Public IP address are the ones that you can share to um, people outside of your network, outside of your VPC, right? To come in, right? So if, for example, you want to remember the day we created an EC2 instance and I gave you an IP address, I said put it in your browser, right? So that IP address is the exact IP address of the instance that we created, right? Without that IP address, there's no way that you would have been able to see that congratulations, you successfully launched a instance that we saw that day, right? There's no way you'd have been able to see it. But every resource that you create automatically has a private IP address. A private IP address is what is used to communicate internally. That's what is used to communicate internally. So one thing to note about the internet gateway is that your internet gateway is attached to your VPC. That's why it's like the main gate. The main gate is attached to the school, the entire land, right? The main gate is what is you basically attach it to the entire land, right? It's what is controlling access into the school campus and out of the school campus. So that's why the internet gateway is like your main gate. The second type of gateway, right, is your NAT gateway. Remember I said private subnet does not have a direct access to the internet. But maybe, for example, now you've launch an EC2 instance, right? And that EC2 instance needs to, maybe you need to update it, and the update that it needs to get is getting it from the internet. Now, because it's sitting in a building that does not have access to outside world, right? But it needs this update so that it can function, it will not crash. So what happens is that you are going to create a NAT gateway, right? A NAT gateway is what the building will now be communicating to, instead of communicating directly to the internet. Remember that example I gave about a staff building and an hostel, right? Instead of the hostel students communicating directly to the outside world, they will send whatever errand they have through the NAT gateway. Now, one thing to note that is important to note for a NAT gateway is that it's just a one-way access. You will only be able to communicate from inside the building to outside. People outside cannot come in. You can go through the NAT gateway, that public subnet can go and buy something from the market. But something or someone from outside cannot buy something for you and bring it inside. It doesn't allow that. So the NAT gateway would only allow communication from inside the private subnet that does not have internet access, right? It will only allow communication from inside that private subnet to the internet. It will not allow communication from the internet to the instance. So example of that is from that EC2 instance that you have probably launched now, right? You need to update. You probably need to quickly go to Google to go and download an update. You can go to Google from inside that thing. But you now want to give somebody an IP address and say, oh, come and see what I created. Oh, the person will not be able to access it. The person will be able to access it because it only allows traffic from inside to outside, not from outside to inside. So that's what a NAT gateway does. So a NAT gateway is like a one door that allows the resident or your private subnet resources to look out, to be able to communicate with the outside world, but not allowing the visitors to come in. So it only provides an outbound. There is inbound and outbound. Outbound is basically something that is going out. Inbound is what is coming in. So a NAT gateway only provides an outbound internet access. It will only help you to be able to go and make order for something on the internet, do your update on the internet, and all of those things. But it will not allow somebody from the internet to come into that building. So one of the reasons why a NAT gateway is important, one of the reasons why we have private subnets in the first place, is because you can have resources that are sensitive, that you don't want people to see what is there. Say for example, your databases, it is usually advised or recommended that you put your database in a private subnet. Why? Your database is carrying informations that you don't want people out there to actually see. Say for example, now an hospital, if an hospital has a database for their patients and they put that database on a public, or in a public subnet, in a public building now, right? What it means is that once I have the public IP address of that subnet or of that database, I can go there and see all the information of everybody that you have on that database, right? So that's why for those kind of instances, like the database, it is usually recommended that you put it in a subnet that does not have internet access. But if that database now needs to be updated or something, so it means that that database has to be able to communicate to the internet. But you don't want people over the internet to be able to communicate to see what is inside that database, right? You can now use a NAT gateway. So you attach a NAT gateway to that um subnet, right? So the database will be communicating from the NAT gateway to the internet. And because the NAT gateway is only a one-way traffic, it only allows outbound traffic. So it will allow you to get your update from the internet, but it will not allow people to access that database from the internet. Hope that is understood. Is there anything confusing there? Do we get that? Okay, so Levina, let me know, just type in what exactly you want me to go over. So maybe because you've just joined, you joined quite late, you probably don't understand all the subnet and everything that I had explained earlier on. Oh, okay, now, so just take it small by small, right? Um, Again, we said that subnets are what, buildings inside your land. You don't want, you have like a sensitive document that you want to put in a particular building. Now that document, you don't want people to get it, right? But you want that particular building to be able to get update from outside. So you use a NAT gateway. The NAT gateway is what is going to allow that's your building to get things from outside. But anybody from outside cannot enter into that building. Okay, so I like that a lot of people said yes. What did Mr. Gbenga say? Oh? What did Mr. Moses say? Mr. Moses is Mr. Gbenga, by the way. Like a gunshot away. Ah, please don't let us be thinking of gunshot. Oh, Mr. Moses, because let's not think of gunshots in this economy. All right. So we can move on to the last gateway now, right? The last gateway is, oh, it's like a lot of people joined late today. So sorry. So the last gateway is the VPN gateway. So a VPN gateway is like a tunnel, right? That connects your VPC to like another, include another VPC or another network entirely. Remember we said that your on-prem now is like another cloud, it's like a private cloud. So if you have, maybe you have your database on your on-prem, for example, and your application is on AWS in your VPC. Now you want the database that application will be taking to work, right? The data it needs is sitting in that database. Ordinarily, there will be no way for the AWS environment to be able to communicate to your on-premises environment, right? So that is why a VPN gateway is now needed. So a VPN gateway is like you are creating a tunnel, like a back end tunnel, right? It's not in the main gate, because main gate will allow everybody to enter. You don't want a main gate. You want just a tunnel that will allow communication between your on-prem and that particular AWS environment. So you use a VPN gateway. So it's like a tunnel that is connecting two different campus together, allowing them to communicate. So anybody from the on-prem wants to enter into the school, maybe they want to quickly get to the hostel, they can pass that tunnel that was created. So your VPN is like your secret tunnel that is secured, basically. So that's about VPN gateway. It's as straightforward as that. Do we get that? Can we move on? Okay. All right. Thank you very much. Okay, so what are the rules for gateway? Now, please pay attention here, right? Number one is that what your internet gateway, right? You can only have one for every VPC. It's like saying you can only have one main gate for every campus. You can only have one main gate for every campus. So any traffic from outside has to go through that main gate, basically, right? Every internet traffic has to go through the main gate. So you can only have one internet gateway per VPC. You cannot have two internet gateway attached, right? Then for your NAT gateway, and this is where it gets interesting. Remember we said that your NAT gateway is what is going to allow a private subnet to be able to communicate to the internet, right? Now, that NAT gateway has to be sitting in a public subnet. So, what will happen, and I will show us in a diagram later on, right, is that you are going to create a NAT gateway. You put that NAT gateway in a building or in a subnet that allows access to the internet, right? What will now happen is that your private subnet would now connect to that NAT gateway. So in your route table, remember I said route table is what determines your rule. So what will now happen is that your route table will now say this is the direction for communication. Whenever this student in this building or in this private building wants to communicate to the market, they have to go through the NAT gateway. So instead of just going into the main gate directly, no, they will not get to the main gate. They will go to the NAT gateway. So the NAT gateway will now help them to go and buy whatever. It's like they will write their list of things that they want and say, okay, I want to do an update. I want to do this. I want to do that. And then they pass it to the NAT gateway. Because the NAT gateway is sitting inside a public building, is able to help them get those things and bring it to them. But somebody now cannot say that, oh, I want to now enter into this private building because through the NAT gateway. So that I would say the NAT gateway only allows one-way traffic outbound. It will only collect information from the private subnet to the internet. It will not allow anything from the internet to come into the subnet. So please take note of that. Don't mix it up. Don't say, oh, because NAT gateway allows access. It's just like saying, like that example I gave about maybe your staffs that helps you to run errands, right? The students are in a private hostel. They are now allowed to go out, but they need to quickly buy food that they need to eat. Their food stuff is finishing. They need to quickly um what's the word now? They need to update their stock, right? They can't go out to the market. Their parents cannot come in and buy something from the market and bring it to them, right? Because they don't have access to the main gate, they don't have access to the internet, right? So what will happen is that there's a particular staff. Now that staff is going to be sitting in a public building, a building that have access to the main gate, that has access to the internet. So when these students now want to say, oh, my food stuff is finished, I need food stuff, what they will do is that they will now go and meet that staff that is inside the public building and say, please, oh, this is what I need, help me. So the person will now go and buy those things and bring it to them. That is the only way NAT gateway. But if maybe the parent comes now and say, I bought this thing for my child, or help me give, they will not answer. They will not allow the parent to come to the children. They will only allow the children to send them errand to go and buy something from outside. So for that to happen, the NAT gateway has to be sitting in a public subnet. You cannot put the NAT gateway in a private subnet, because if you put it in a private subnet, it means that it does not have access to the internet. Hope that is understood. So please take note of that. The NAT gateway must be sitting in a public subnet. Do we get that? Okay. All right. Thank you. All right. Thank you very much. So, um, of course, I've already talked about the fact that you attach your internet gateway to the VPC, right? It's like your main gate. Your main gate is attached to the campus. Is attached to the campus building or the campus land, basically, right? Not It's not attached to any particular building. It's not attached to a subnet. Your internet gateway, which is I said is like your main gate, is attached to the VPC directly. Then your NAT gateway, again, like I said, is placed within a public subnet. Then to your VPN gateway is what you would set up to connect securely to another campus, like your on-prem environment. All right, so let's put all of this together, right? And I want to use this diagram. Let me stop sharing for a bit, right? More minutes. Let me stop sharing my slide now and share something else. Um, okay, all right. So it should be coming up any seconds now. Please let me know when you can see my screen. Can we see my screen now? Let me know what you can see on my screen, so I know that I'm sharing the right thing. Oh, not yet. Um. Okay. All right. So they are sharing it now. Thank you very much. I was about to just call. Okay. All right. So I think we can see it now. Okay. All right. Okay. So let's draw together. We're going to be doing some drawings together. There's an already made drawing, right? But I want us to do this together first before I go to the already made drawings. Okay. So remember I said the first thing is what is your VPC. So let's draw our plot of land. Please don't mind that my line is not straight though. Nobody should laugh at me. So let's say this is our VPC basically. So uh, VPC. So inside the VPC, what do we have? Let's do this together. Inside the VPC, what's going to be there? In your VPC, what will be there? In your VPC, what will be there? Tiffy Cornell, I said, don't laugh at my drawing. You say you're laughing in Spanish. All right. So thank you to everyone that said subnet. So we're going to have subnet. Let's say, for example, this our VPC as a CIDR of let's say 10.0.0.0 slash, let's say 28, right? This slash 28 means that what we can only have 16 IP address. Or let's make it bigger. Let's make it 24. Let's not make it that small. So this means that we have 256 IP addresses, right? So um inside the VPC, like you've all said, we will have subnets. Subnet is like our building, right? So let's say this is subnet 1, this is subnet 2, subnet 3. Um let's name it subnet 1, subnet 2, subnet 3, right? So each of these subnet now, let's say this one is it has a CIDR block of 10.0.1. Remember, your subnet CIDR must not overlap, or 0 slash. And also remember that your subnet CIDR cannot be bigger than your VPC, right? So let's make this 28. Let's make this also 28. So 10.0.2.0 slash 28, right? 10.0.3.0 slash 28. What does this slash 28 mean? It means that for each of these subnets, they will only have what, 16 IP address, which means that I can only put just about 16 rooms here, right? I can only build 16 rooms inside this building, or 16 IP address, or 16 resources inside this subnet, right? That's what this slash 28 means. So another thing to do is what? We want to attach an internet gateway. So let's draw our internet gateway. So this is our internet gateway. Remember that your internet gateway is what? It's supposed to be attached to the VPC, not to the subnet. It's supposed to be attached to the VPC. So this is the internet here. This is your internet, right? So this is the internet. This is the internet gateway. We are going to say internet gateway is IGW, right? So internet gateway. Now we now have what? A route table. We're going to have a route table. For this one, this is the route table. Please don't mind my drawing now. Route table, route table. Remember that every subnet must have what? A route table. Now, what would determine, let me do something and I want to see if you guys can get it. I'll be so proud of you if you can get it. If this route table has a route to IGW, this is not how they write it though, but just example. Route to subnet 1. Route to sub subnet 1 and 2. Please just ignore my drawing as long as you can get. Which of these subnets do you think will is a public subnet? Let me add one more thing to confuse us. Route to IGW. Which of these subnets, subnet 1, looking at the routes table that I have attached to each of the subnets, which of these subnets do you think is a public subnet? Remembering that public subnets means a subnet that have access to the internet. Which of these subnets do you think has a is a public subnet? I've only seen for Solar respond. Look at it very, very well. Okay, subnet 1. Someone says subnet 2. Okay, all right. So, from what I've seen, I see that a lot of us kind of get the idea. Yes, so Tejiri, Jennifer, yes, so Tejiri and Jennifer is the one that has gotten the answer so far. And why is that? If you look at subnet 1, it has a route to the internet gateway. And once they have a route to the internet gateway, it means that they can communicate to the internet. And we said that what makes a subnet a public subnet is the fact that they can communicate to the internet, right? So subnet 1 has a route to the internet gateway, which means that it can communicate to the internet and the internet can communicate with it. So subnet 1 is a public subnet. Now let's look at subnet 2. Looking at subnet 2, the routes that are there, it has a route to the internet gateway and it has a route to subnet 1. What this means is that what? This particular subnet can communicate to the internet. It will allow traffic to the internet. It will allow traffic from the internet. Another route that is there is also that what? It will be able to communicate to what? Subnet 1. So in this particular subnet, there are two routes that are two instructions that has been given. Number one is that what? You can communicate to the internet gateway, which will allow you to communicate to the internet, and you can also communicate to subnet 1, right? So this subnet is a public subnet. Why? Because it has an instruction, a route. It has a route to the internet gateway. It has a route instruction to say, okay, you can reach the internet gateway. Once it has that route instruction, it makes it a what? A public subnet. Because what makes a subnet public, what determines if a subnet is public or it is private, is if it has a route to the internet gateway. So this one now, what it simply means that it can communicate to the internet and the internet can communicate with it. That's number one. Number two is that what? It can communicate to this particular subnet 1, right? It allows traffic to this subnet 1, basically. So, but it does not have a route to subnet 3, which means that this building here cannot communicate to this building. Students that are here cannot go to this place. Why? Because there's no route, there's no map that gives them the direction. Remember, we said that it is whatever it is written in this map, in this route table, that is going to determine access to the road that will lead to different places, the direction, right? This particular subnet does not have a um a direction, so to say, to subnet 3, so it cannot communicate to subnet 3. Subnet 1 can only communicate to the internet. It cannot communicate with any other subnet that is here. Now, subnet 3 is a private subnet. Why? Even though it can communicate to subnet 1 and 2, it does not have an instruction that is communicating, a direction that is communicating to the internet gateway. So your subnet 3 is what? Is a private subnet, while your subnet 1 and 2 is a public subnet, simply because they have a route instruction to what? To the internet gateway. Do we get it? Do we get that now? Olayemi, what happened to my face? Facing my face. Okay. All right, Jennifer. Thank you very much. I remedy. Thank you. So let's leave this drawing. This is my drawing that is not fine. Let's leave it, and let's get back to our slide that has a final drawing. Let me stop sharing this one and go and share. Please don't laugh at my face for lying me. Let's go back to sharing our slide. Okay, so put it all together. So let me know when you can see my slide. Admin, please help me put the slide back. Oh, good. Thank you very much. Moses said I've told you to answer. Yay. I'm sorry. All right. So we can see my drawing is a true work of art. Deborah, God will judge. The Lord is watching you. Okay, so now let's use this fine diagram now to explain everything. And this is going to also mention some of the things I've probably not mentioned before now, right? So you have your AWS cloud. This first box that is here, this first black box is the AWS cloud, right? It's like your Lagos state. Then you now have your VPC. Now, please remember, whenever you are provisioning your VPC or you are creating a VPC, your VPC is going to be sitting in a region. Your VPC is going to be sitting in a region. So you have your VPC. See the slider block for the VPC here. The slider block for the VPC is a /16, which means that this VPC would allow 65,536 IP addresses, right? Now, inside this VPC, you have your subnet. Please take note that your subnets are always created inside an availability zone within that region. Say, for example, you've created your VPC in um, US East region, right? And maybe US East region has availability zone 1, availability zone 2, availability zone 3. So you can decide that, which is your choice. You can decide that you want to create your first subnet in availability zone 1. You can decide that you want to create your second subnet in availability zone 2. You can decide that you want to create all your subnets in availability zone 1. It is left to you, right? But it is usually recommended that you create them in different availability zone for redundancy purposes, right? And for availability purposes, so that in case anything happens to availability zone 1, you can still have your second availability zone up and running. So depending on your choice. So in this diagram now, we've created our VPC. Our VPC is as a CIDR block of /16, which means that we can have 65,536 IP addresses, right? Now, the first, also note here that we have an internet gateway in this VPC. Please, I think I didn't mention before, if you do not attach an internet gateway to the VPC, if you don't attach an internet gateway to the VPC, everything that is inside this VPC will not be able to communicate to the internet. Every single thing within this VPC would not be able to communicate to the internet. It's like you've built a campus, but you did not put a gate, you not put a main gate. So there's no way anybody wants to enter. There's no way anybody wants to go out. Right. So please let's also take note of that. So you have your internet gateway here, right? You have the first subnet. Remember, I said your subnet is what is going to be housing your resources. So you have created EC2 instances in this subnet. You've created EC2 instances in this subnet. Now, see your CIDR block for the subnet 1/24. The second subnet is also /24. The third subnet is /24. The fourth subnet is what? /24. Now, what does that mean? It means that this subnet is going to have what? 256 IP address, which means you can have about 256 different instances here, each having different IP addresses, right? This second subnet also has 256. This one has 256. This one also has 256. If I'm going to ask, in this VPC, can you still create more subnets? Can you still create another /24 subnet? Yes or no? Yes, Ayomide. Levina, yes, you can spread your subnets in different availability zone. So, yes, thank you very much, Patience and Mayowa. Okay, all right. So more answers have come in. So yes, you can create more subnets. Why? Because our VPC has IP address of what, 65,536, right? And so far, we've not even used up to 10% of it, right? Because if you had this one has 256 IP, 256 IP, that's what, 512, right? This is another 512. So 512 plus 512 is about 1024, if I'm right. Actually 1024 IP address. So you've only used 1024 IP addresses, right? Out of, or you've only provisioned a building that can occupy 1024 IP addresses out of 65,536. So you can create many more slash 24 subnets, many more. But can you create a slash 16 subnet? Can you create a slash 16 subnet again? No, thank you very much, Christophine. No, because that would be what? Building more than your land capacity. That will be trying to build more than your land capacity. All right, so let's quickly move ahead, right? So you can see the router here. The router is usually is not something you see basically, but it follows the instruction of the route table. Now, I want us to pay attention to the lines that are attached to each of these subnets. If you look at this subnet here, right, it's going to this router. These two subnets too are going to this router. This color of this one is what's green, the color of this one is blue. Now, if you look here, the route table that is attached to this particular subnet is what? Is carrying a, so whenever you see this IP address here, I think I've mentioned it before in one of our classes. Whenever you see 0.0.0.0.0 slash 0, right? It means any traffic. It means any kind of traffic, right? And the target is what? Internet ID. So what this route table here is saying that what? Allow this particular route instruction now here is basically saying that any kind of traffic can come in through the internet gateway, right? So you can allow internet traffic. You can allow internet traffic through the internet gateway. So that's why you have the internet. The target is going to be the what? The internet gateway ID that you have attached to this VPC. So which means that these two subnets here, and that's why they were named public subnets. Why? Because they are connected to a router that has an internet gateway access. Now, remember I also said that at the point of creating your subnet, an automatic a default route table is created for you, right? Now, the default route table always would have this route instruction, which is an instruction to communicate within, so anything that is within this CIDR block, any IP address that is within this VPC CIDR block, they can communicate with each other. So it allows local communication. Students can communicate with staff can communicate with a security guard, basically, as long as they are within this land. They are not going out of this land. That's the first route instruction that you have in every subnet that you create. That is why you find out that even these ones, they also have it. Now, let's go to this second set of subnets that are here. Their own line is what? Is blue. This is the route table that is attached to them. Now, the route table does not have internet gateway instruction, which means that it cannot connect to this internet gateway. That is why it is what? A private subnet. It does not mean that you are going to name your subnet private subnet, but you would know. But I used to advise that when you want to name your subnet, name it in a way that you can understand that okay, this one is one that have internet access, this one that not have internet access, right? So These ones we can call them a what? A private subnet. Why? Because they don't have internet, they don't have access. Their route table is not carrying any instruction to the internet gateway, but it is carrying an instruction to another gateway, which is a VPN gateway. If you remember in the when we were talking about gateways, we talked about a VPN gateway, and we said it's like a tunnel, right, that allows private connections between different campus. Now, this route table is carrying an instruction to this VPN gateway. So this is your on-premises data center. You want what is inside this on-prem to communicate to this place. So what you will do is that what you will say, this one, oh, I've created a gateway, a special tunnel. I've dug a special tunnel. It is not in the main gate. It is not in the internet gateway, right? That tunnel is not passing through the main gate. It is a secret tunnel for only this my on-prem and this subnet to be able to communicate. So that's why I'm putting a route instruction to say, if anything is coming from here, oh, it must pass through this VPN gateway to come and talk to me. Or if I want to talk to this on-premises data now, I have to pass through this VPN gateway. If this VPN gateway is not there, right? If I don't have an instruction to this VPN gateway here, there's no way these two people will be able to communicate. Now, also know that these ones here will not be able to communicate to this one because this instruction is not in their route table. You can add this instruction to this route table. If I add this, remember we said that your route table can be updated, you can delete, you can add to it, right? I can decide that, oh, I also want my public subnet, these two subnets, to also be able to communicate to my on-prem data center, right? What I will just need to do is to carry this address and also add it here. So I will say, okay, allow any kind of traffic to come from this virtual private gateway, which means that my on-premises data center, anything that is sitting on my on-premises data center, will be able to communicate with my public subnet as well. So you see why the route table is what is important. Do we get it so far? This customer gateway, for now, it is not your headache. Why? Because a customer gateway is usually a gateway that is sitting with the customer, is sitting on the on-prem. It is not something that you create yourself, it's something that the customer already has, right? So you can create a site-to-site VPN connection. Now, a site-to-site VPN connection, right, is going to make use of the customer gateway and the VPN gateway. So VPN gateway is the one that you create on AWS. The customer gateway is with the on-prem. So a VPN connection is one that will say, okay, this VPN is one that is representing this subnet. This customer gateway is one that is representing the on-prem. So it's bridging the gap, basically. Do we get? Now, looking at this table that is here, you see these instances, right? These are the IP addresses. Remember I talked about IP ranges. We said CIDR block is what tells you the amount of stuff that you have, right? The amount of public IP addresses that you can have in a subnet. But your IP ranges is what would list out those IP address. So in this one now, right, we have 10.0.0.0.0/16, which means that we can have what 65,356 IP address. Now, for this public subnet, right, his own CIDR block is 10.0.1.0/24, which means that it can have what 256 different IP, which means that each of these instances that are there that you have created, this instance 1, instance 2, instance 3, they can have IP addresses. These three now will take just three IP address, right? Because they are unique addresses. So if you look at their IPv4 address now, it's going to be 10.0.1. Remember, that is where they are sitting. The public subnet they are sitting is carrying 10.0.1.0. So it means that these instances can have an IP address of 10.0.1.0, 10.0.1.1, 10.0.1 .1.2, 10.0.1.3, and so on, up until 256. But I also said something, if we can remember. I said for every CIDR block, remember that AWS will reserve 5. So instead of 256 IP address that you can have here, you can only have make use of 251, because AWS will do what? Reserve 5 for themselves. So you see that the IP address for the first instance is 10.0.1.5. The second one is 10.0.1.6. The third one is 10.0.1.7. Right? Mr. Moses will be teaching us about elastic IP address tomorrow. So let's not touch that for now, right? So do we all understand how all this comes together? Do you need me to? Oh shit, it's past 9. Do you need me to go back on anything? I want to believe no. I want to believe no. All right, so I'm so sorry. I lost track of time. Okay, so this you can read up in the slide when it is shared to you. Best practices. Um, there are links that you can also read up on, and can we still take questions? Please, you can send your questions to me personally. Would have just done knowledge check, but I don't know. Can we still have like 3 minutes for knowledge check? Admins, should we use like 3 minutes quickly to our knowledge check? Yes, no, yes, no, yes, no, no. Okay, so the first response I saw is no. So please, at some point, we almost started answering the question. Okay, all right. Um, Ulushola, please, you can reach out to me. Thank you very much, and we'll deal with that. So, for those that said B, yes, B is the right answer. The second question is, which of the following describes a subnet in an AWS VPC? And we're just going to take these two questions, just these two. Which of the which of the following best describes a subnet in an AWS VPC? A B A B A B. Okay. All right. So let's check the answer. So your subnet is not a collection of IP addresses, that is used to connect to internet. Your subnet is like different buildings that you use to separate your resources, right? Remember I said that if you have um you are buying laboratory equipment, you cannot just put them anywhere in the VPC, right? You need to put it in a subnet. So you have your subnet is like different buildings that are housing different resources. So you use it to separate your resources. So you separate a bed and bunk that is supposed to be in a hostel. You will not be putting it in a laboratory, basically. So the answer is actually A. The answer is actually A. All right. So I'm going to stop here for the night. I'm so sorry that I've used our time, 5 minutes extra. I think we can all call it a night. All right, so please feel free to private chat me, reach out to Mr. Moses as well. You can drop your question on the Telegram chatbot. So anyone, I'm available to answer your questions. All right, thank you everyone. Thank you so much, everyone. Have a wonderful, wonderful night rest. All right, bye everybody.